Okay, there's our famous formula for resonant frequency. There it is there, resonant frequency. Fr is equal to 1 over 2 pi times the square root of LC. And a few people studying for their advanced were asking me, well, how do you get that formula? Where does that formula come from? Well, very simple. When a series or parallel circuit is at its resonant frequency, the inductive reactance, XL, is equal to the capacitive reactance, XC, and they're opposite signs, so they cancel out. And that's kind of the definition of resonance, where the inductive reactance is in the positive Y direction, and the capacitive reactance is in the downward Y direction, so they cancel out, and leaving just the resistance there. Okay, so let's just use two little formulas. One is, I don't know if you can see that, XL equals 2 pi FL, and XC equals 1 over 2 pi FC. Okay, there we are. Well, our F is a little squiggly there. So if they're both equal at resonance, let's just make them equal. Okay? We're going to make them equal and then solve for the frequency, because F is the same here. We're just going to make these two things equal, set them equal to each other, and then solve for F. So we'll go 2 pi FL equals 1 over 2 pi FC. So 2 pi FL is equal to 1 over 2 pi FC, and that's at resonance. So there's a few little ways we can solve this. I think the easiest way to visualize is we want to get F here by itself. We want to get F by itself. And the easiest way to do that is we're going to make this side equal to 1 by multiplying by 2 pi FC, because this is 1 over 2 pi FC. So we'll just multiply by 2 pi FC. 2 pi FC. And, of course, we'll have to multiply the other side by 2 pi FC. So what it's going to be is 2 pi FL times 2 pi FC, and is equal to, well, if you multiply 2 pi FC times 1 over 2 pi FC, you'll get 1. These will cancel. So that cancels, and that cancels. So you get 1 on this side. Okay, we're a little closer now. But bear with us. So 2 pi FL times 2 pi FC. We'll just multiply it out. It's going to be 2 pi squared, actually, isn't it? 2 pi times 2 pi. 2 pi squared. F squared times L, right? Times L times C. Okay, so 2 pi squared, F squared, LC. That's just the consequence of multiplying up here. And of course, that's still equal to 1. All right, very good. Excuse me. When you have a square on one side, it's pretty easy to take the square root. So let's just take the square root of all of this. Put a square root sign up there. And of course, we'll take the square root of the other side, right? Because like we multiply by 2 pi FC up here, to make this equal to 1, we have to multiply the other side by 2 pi FC, which we did here. And this time we're taking the square of both sides. So I know that looks like 1 over the square root of 1, but let's just ignore this 1 here right now. Okay, so the square root, and we can do this under the square root sign because it's all multiplication here. So the square root of 2 pi squared is just going to be 2 pi. 2 pi. And the square root of f squared is just going to be f, right? I'll put a bracket around it. And of course, we're stuck with LC, so it's still the square root of LC. And of course, that's equal to, the square root of 1 is just 1. And we're almost there. Now, we have all this on this side and 1 on this side. All we have to do to get F, which we're looking for, right, the resonant frequency, F, is just divide this side by 2 pi square root of LC to get F there by itself. So we'll divide, paper's moving around on us, by 2 pi and square root of LC. All right, so that will cancel, and that will cancel. And of course, on this side, we have to divide, right, by the same thing. So we're going to divide by 2 pi and the square root of LC. Okay, now that has canceled. All we're left with is F. So this is our final line here. F is equal to 1 over 2 pi times the square root of LC. And of course, that is our handy-dandy formula. And I'm just going to put a little R there because that designates resonant frequency. And that's the same as the formula that we started with up there. So a very simple little bit of algebra there. And that's the resonant frequency. 1 over 2 pi times the square root of LC. And of course, L is in Henries and C is in farads. So if you get, whoops, what's down here? If you get like micro Henries, microfarads, you have to deal with micro and micro or whatever. But there's your basic formula there. And I think I already have a video on here that that we use that formula to determine the resonant frequency. Okay, thanks for watching. Hope you enjoyed and hope it's a little bit helpful. And please forgive the roughness here. I'm doing this with a camera phone and very, very, well, not the greatest in lighting.